Hello, Pine Hollow pilots. This is Mr. Osterstrom, also known as Mr. O. I am one of the three science teachers at Pine Hollow in sixth grade, and I'll be happy to narrate this set of flip notes on standard 6.E.1.2, which is technical terms for solar system, parts of our solar system, and why Earth sustains life. Before moving forward, remember flip notes give you four valuable tools to have. This first one is the power to pause. So as you're taking notes from this video, you're able to pause on each slide and jot down the content being covered onto your note sheet to allow you to get the content you need for assignments and activities from it. You're also able to rewind the video. So think about in class and you miss something or you don't quite get it written down or heard it correctly. You don't have to raise your hand and ask someone to repeat it for you. You can simply rewind it as many times as you need until you have what you need, and then just hit play to continue on. Third one is the most valuable tool is if we're covering something or if I'm covering something and it seems confusing, unclear, it just doesn't seem right, please make a note and a question of it. So when you meet with your teacher, when this content's being presented, you're able to ask these questions. That's where the valuable discussions from notes happen. They allow you to dig deeper into things that you are uncertain about. And I'm pretty sure if you're uncertain about it, someone else may be in class as well. And you can enrich everyone's learning by having this conversation that goes deeper than just what we cover in the notes. And also, you have the ability to refer back to these in assignments whenever you need to. So if you get an activity or a project or a quiz and you just don't remember the content, go back to this. Use it as your tool to help you remember what was covered and what is and what is not. There is two types of note collection options. You can use the Google Doc. It will have the same name as the standard that we're covering. So it's 6.E.1.2. It's called Solar System Note Outline in Google Classroom. When you click on that, it will make an own copy for you. The slides are done in order of that handout. So as you go, you just complete it as you go. And you can go old school if you choose. You can grab a piece of paper and write the notes down. I would definitely try to urge you to do number one. It keeps you organized. It keeps things straight. It makes it neater and easier to read and use. However, either one you choose is fine as long as you choose an option. So this is what really, when we say solar system, this part of the solar system is really what you're thinking. You're starting to think of like planets and what's it made of and what things look like. And this is the cool stuff in my opinion. So let's start with just noting what our solar system is consisted of. And this first one is going to be obviously the sun, the biggest thing in our solar system, the thing that everything goes around. Then we also have 8 planets. We also have moons. Now Earth has a moon, but there are way more than just one moon in our solar system. And then you have asteroids, mostly found in the asteroid belt, and the asteroid belt actually separates the inner planets from the outer planets. We'll talk more about that later. Then you have meteors, and when we get into meteors, there's meteors, meteorites, meteoroids, and we'll talk about the differences of those in class as we go further into different activities. We also talk about comets, and actually comets become part of the previous standard when we talk about predictable patterns because Halley's Comet is predictable. We'll talk more about that as we go. We have gas and dust make up the solar system. And the last but not least is empty space. And the major thing that consists of solar system the most is empty space. There's a reason why we call it space because it's mostly filled of nothing, the in-between. So we'll talk more about that. But these are the 8 major components of what makes up our solar system. Let's first talk about the sun, that beautiful image of the sun. The sun is the major source of heat and light for the entire solar system. Now, obviously, the closer you are to the sun, the more heat you get from it, but the sun's light gets as far out as can be. It keeps going on and on and on. Light being an EM wave, which we'll get into in a different unit, talks about how light will continue to go on until it actually hits an object. Everything in the solar system is under the direct influence of its gravitational pull. The sun is so large, it's able to pull every planet around with it. Now, if you understand the solar system at all, you'll understand some planets, especially the gas giants, get really, really large. However, the sun is significantly larger to actually pull it around together. Now, the sun is the only star we have in our solar system. And if you think about different stars, The sun's actually a smaller star. So we'll address that in later units, but keep that in mind. Let's move on to planets. I have this image here, and I'm going to talk about this image in just a minute. They are the largest objects in our solar system if you don't take the sun into consideration. Obviously, the sun is far larger than the rest of them, but when you get the sun out of there, the planets are the next largest thing. They revolve from the previous standard revolution around the sun with known frequencies, meaning you can look up how long it takes Mercury, Venus, Earth, Mars, Jupiter, Saturn, Uranus, Neptune, and to the time know how long it takes to go around the sun. Those don't change. Just like the sun, we go around the sun in 364 and a quarter days. Each planet has a different revolution period, but they are known. That's why it's a frequency. And they also revolve around the sun in near circular orbits. It's called an elliptical orbit. We are actually an elliptical galaxy, but they are nearly circular, but they're not quite perfectly circular. I leave this up here to show you that Pluto is the oddball. Now, back in the day when I was in school, Pluto was the 9th planet. But since then, it's been demoted to a dwarf planet. One of the major reasons is because of its orbital period. There's a place where it stays on the outside, but then it'll orbit inside. It's odd. The frequency is not quite right. There's other reasons why Pluto's not a planet, but that was a major one of the factors. Let's talk about the order of the planets if you start from the sun working your way out. The first would be Mercury, Venus, where you live, Earth, Mars, and those are the 4 inner planets. Then you get into the outer planets, which is Jupiter, Saturn, Uranus, and Neptune. So let's start with looking at the inner planets first. They're called the inner planets because they're inside the asteroid belt. Here's the inner planets. They're rocky and terrestrial, meaning that they're mainly made of rock. They have life on them. Some of them do, or some of them did. Then you have the 4, and I put them in order the way they are from the sun out. But in general, they are smaller when you compare the inner and the outer planets. In this unit, we'll compare the inner and outer planets often. The first factor, you'll figure out what are they composed of, and the big difference is these are made of rock and that they're smaller. They also have few moons. Some have no moons. They don't have any rings, but they do have craters, rocks, mountains, volcanoes. They have stuff like that. They just don't have the rings like the outer planets do. And they have craters and rocks because of their composition, what they're made of. I put this picture before we do the outer planets because you need to see the size difference. And you can see the sun, you can barely see an edge of it. And you can see how small Mercury, Venus, Earth, and Mars is. Now, Earth, the one we live on, is the largest of the inner planets. But Venus is pretty close. When you get to Jupiter, and Jupiter's by far the largest outer planet, and then Saturn, Uranus, and Neptune. Now, the outer planets all have rings. They're not shown here. Saturn's rings are always shown just because of how distinct and it's known for those rings, but all other ones do have them. Pluto and Charon's moon is out there. You see it, but you can tell the difference in sizes. And look at Pluto. I mean, another reason why it's been demoted to a dwarf planet. It's out with the gas giants, but look at the size of it. Outer planets, they are called the gas giants for a reason. They're mainly made of gas, but they're giant because they literally are giants. Jupiter, Saturn, Uranus, and Neptune working your way from the sun out, or the asteroid belt out. And then they are generally larger, so when you're comparing the inner and outer, the outer is definitely larger. Sorry about that, hit the wrong button. They are gaseous planets. They have multiple moons. I mean, they have up to 60 plus moons, and then they have rings and bands of like ice and rock, and they also have clouds. There's storms on certain, like the picture of Jupiter, you can see the storm that's happening on there. We'll talk more about that when we get into class and the different activities. Let's look at moon or moons for that example. Our moon orbits the Earth. That's not the only thing that orbits the Earth. So the moon is known as a natural satellite because it was made naturally. There's also artificial satellites, GPS, NASA satellites that are put out that go around the moon. International Space Station would be an artificial satellite. There's also debris in space that's been out there. It's obviously you're not going to have a cleaning crew out in space picking stuff up, but those things are also in orbit around something. Some planets have a variety of moons, even have flat rights of rock. I mean, none of the inner planets have a variety of moons. I think Mars has two. And the ice particles that orbit around them, the flat rings and ice particles, deal with the gas giants. And some of these moons are so large they even show geological activity on them. So that just shows how large they are in composition wise, big enough to have geological activity. Planet Earth. Now, this is the other part of this standard. So you have this what makes up the solar system in this standard, but you also have what makes Earth unique. And Earth is unique because we support life and no one else supports life. Now, when we get more into it, you're going to see that there probably was water and life forms on other inner planets before their atmospheres broke down. But currently, planet Earth has an atmosphere, which is a layer of air, which is a layer of many gases, not just air, that surround the Earth's surface, and they keeps humans safe from the sun's radiation. And when we get into the magnetic field that comes around the Earth, because we have this magnetic Earth, we block solar radiation that would be hurtful from the sun. Because we have this magnetic field around us, we are safe. So the atmosphere, magnetic field, we block the sun's radiation for allows plants and humans and animals to all live. But there are three ingredients for life for any planet. And if you have to have all three to have life. So the first of which is liquid water. Liquid water, I know, is a double negative because water is liquid, but it has to be liquid form, rivers, oceans, type like that. You have to have a breathable atmosphere. Other planets have atmospheres. However, they're containing like harmful gases, which doesn't allow you to breathe there. So it has to have a breathable atmosphere. And you have to have a suitable amount of sunshine to sustain life. The Earth is known to be in the Goldilocks zone, which is just further away from the sun, but just close enough to get enough heat, but not too much heat. You have to get enough sunshine to support the plants, and plants support life. So you have to have that suitable amount. That's a really finicky thing. So if you think about these three factors, Earth is the only one that has all three, which is why you have to have all three to sustain life. And this is why Earth is unique. So keeping in mind this standard, you have what makes up the solar system, but the other really large part is why we sustain life. And the only thing I didn't put in these notes is the magnetic field, but we're going to get into that in class more. But keep in mind, if you have any questions about this slideshow, have them written down. So when we talk as a class, you can ask them or ask your teacher. And I hope all is well, and I look forward to seeing you in class soon.